Hey guys, Mrs. Traver here. We're going to walk through our notes on section 12.2, frequency and histograms. So frequencies and frequency tables and histograms are a good way to represent data. In these notes, we're going to walk through a frequency table, a histogram, a couple histograms, I should say, and then we'll do histogram distributions and look at cumulative frequency tables. So there's a bunch on here. Let's jump in. So on this first set, we're looking at a data set that's talking about number of home runs. Maybe this is across teams or across seasons, but our game plan here is I like to first notice what the smallest and largest numbers are, the minimum and maximum, which are in this case 2 and 7. So what we're going to do is starting at 2, work our way up to 17 in intervals, and we get to decide how far apart our intervals are. So looking at this data set, I've got a total of from 2 to 17. That's 15 different, 15 as a range. So if I had gone by ones, that would have been 15 rows, which would be a lot. We might want to cut that down a little bit. I think that it'd be nicer if there weren't as many, so maybe we cut it in 3s. So we'll count by 3s for this one, and we'll do something different in each one depending on the data set. So for this first one, let's count by 3s, and we're going to start with 2. So 2, 3, and 4 are all in one set, so I'm going to put from 2 to 4. Next, after 4 would be 5, 6, and 7, so I'm going to say from 5 to 7. After 7 is 8. 8, 9, and 10 are all in the same set. After 10 is 11. 11, 12, and 13 are all in the same set. After 13 is 14. 14, 15, and 16 are all in the same set. And then my last set, starting at 17, because I have to do the full set even just though it's without one number, 17, 18, and 19 are all in the same set. So there's all my intervals, and we'll create a table with them. Should have made my numbers a little bit smaller. And then we want to label our table as well. So the numbers on the left are intervals. Those were the home runs. And then the other label is for our frequency. So frequency means how many times that something happened. So how many times did a home run get hit? 2 to 4 times. So we just need to make a tally for each one. You could go through, count up all the 2s, 3s, and 4s and mark it here and cross them off as you go. But I find it much faster if I work through the list from left to right and then tally all over the place. So 7 goes here, 17 here, 14 here. You'll get the hang of it pretty quick once you get in the groove. I don't think I need to talk you through this part, so go ahead and fill it in on your own. And see if yours looks like mine. I've got 3, 4, 2, 2, 2, 1. So what's nice is we can look at this data set and we can kind of get a holistic view of the data as opposed to looking at it as a set of numbers kind of randomly written out. We can look at it like this, and we can see how many tallies are in each spot. Sometimes also you see frequency tables with a number, so that's also a thing as well, especially if you have a lot of them. Tallies are kind of become hard to look at. But here we can see that this data is pretty evenly distributed, maybe with a little bit more of a skew to the left-hand side, with less home runs than more. Try out this battery life in hours one. I'm going to pause my screen and fill in mine, so please pause your video now so you can see how this one looks after you check your own. All right, let's see how yours looked. I did actually 2 frequency tables to show both ways. So in this frequency table, I counted in intervals of 3. Notice 9, 10, and 11 is one set. 12, 13, 14 is another. So this one had an interval of 3. And it had 1, 2, 3, 4, 5 rows. On another one, I did an interval of 2. So you can see kind of 2 examples there. Our data sets look similar. Both of them have a lot in the top end, but it's a little bit more spread out when you have a smaller interval. Either of those is fine. Sometimes when you're doing a frequency table or histogram, it'll tell you what interval they want you to use, which is nice. Otherwise, you get to kind of choose how many rows you want to work with. Obviously, you don't want to have like 2 rows. That would be kind of lame. So you want to have anywhere from like 4 to 10 or so. 10 would be for a really big data set. We probably won't deal with ones that huge just because they're a little bit annoying. But any more than that would be a bit much. So anyways, let's move on to histograms. The first thing you do on a histogram is make a frequency table. So we're going to do that first. We've got hours spent watching TV. The min is 0 and the max is 22. If I count by twos, there's going to be a lot of rows. I'm thinking counting by threes would be a good idea. Let's kind of mindset it for a minute. 0, 1, 2, that would be a row. 3, 4, 5 would be a row. That'd be the second row. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. That would be 9 rows. That's a lot of rows. We should probably maybe do a little bit less than that. Let's do 4 as an interval then. That'll give us less rows and a nice even data spread. So let's jump in starting at 0 and going with the interval of 4. So from 0, 0, 1, 2, 3. So 0 to 3 would be an interval of 4. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So that's a good data spread. That's 6 rows. So let's make our labels on the top. We've got hours and our frequency. All right, take a minute and fill those in. All right, here's what mine looks like when I filled in my frequency. So I had 3, 5, 3, 3, 0, and 1. So once we have our frequency table done, from there we can move to make our histogram. So the way this is going to play out is our interval, our hours, will go as the x-axis, and our frequency will be y. So this is kind of an XY table we just created, except our x's are intervals instead of points, and our y's are frequencies instead of heights. So we'll need to give ourselves a XY, and we'll want to leave ourselves some space to label down here for our intervals and here for our frequency. Let's talk frequency first. We need to go from 0 to 5. So I need at least a height of 5. There's nothing that has a higher frequency than 5, so that should be good. And then we'll label that side of the graph. Next, on our x-axis, we want to go from, we have how many? 1, 2, 3, 4, 5, 6. So I need 6 spots. 1, 2, 3, 4, 5, 6. Perfect. And then I usually turn my paper so I can write it in each spot. So from 0 to 3, 4 to 7, 8 to 11, 12 to 15, 16 to 19, and 20 to 23. Notice our numbers are in between the dashes, not on them. That's important. And then I forgot to label this one. Those are hours. So for each one, we just make a height. So from 0 to 3, there was a height of 3. From 4 to 7, a height of 5. 8 to 11, there were 3 again. 12 to 15, 3 again. 16 to 19, none at all. And then 20 to 23, just 1. So last thing we need is a title for the entire graph. So hours watching TV. And a couple things to notice about histograms. They're commonly confused with bar graphs. Bar graphs have spaces in between each. Bar graphs have spaces in between each of the bars, and they also don't have intervals as the x-axis. They have labels. So, for example, a bar graph could be like, instead of numbers down here, it could be like favorite colors in like blue, green, yellow, orange, and then heights of frequency. So it still has frequencies, but it has categories instead of intervals. So it's very different, and that's the main thing that sets us apart there.